The sirens went off in Enid, Oklahoma just before 8:30 on the evening of April 23, 2026. What dropped out of the sky minutes later was an EF4 tornado, one of the most violent storm categories on the Fujita scale, capable of producing winds above 200 miles per hour, capable of tearing well-constructed homes completely off their foundations, capable of turning ordinary objects into projectiles that no wall can stop. The tornado carved through the city's southern side, through the Gray Ridge neighborhood, through farms on the edge of town, through Vance Air Force Base. At least 40 homes were damaged or destroyed. A barn collapsed. Families sheltered in place and waited for the noise to stop. And when the mayor of Enid spoke to reporters the following morning, he said something that was both a relief and a reminder of how close the margin had been. There were no fatalities, only minor injuries. In a storm of that magnitude, across a path of that destruction, that outcome is not the rule. That outcome is luck. But here is what makes the Enid EF4 not just a terrible local event, but the opening act of something bigger. It was not the end of this severe weather pattern. It was not even close to the end. 55 million Americans across 8 states are now directly in the threat zone for the next outbreak expected to develop this coming Monday. The Storm Prediction Center has issued a level 3 out of 5 severe storm risk across parts of the Midwest and Mississippi Valley, covering Missouri, Wisconsin, Iowa, and adjacent states. The Fox Forecast Center is warning of dangerous supercell formation capable of producing large hail, destructive winds exceeding 80 miles per hour, and potentially strong tornadoes. And meteorologists are watching a convergence of atmospheric ingredients: a cold front, a dry line, warm, moist Gulf air pushing northward, and a strengthening low-level jet stream that in this region, in this season, in these combinations, has a documented history of producing some of the most violent weather on the planet. To understand why this is happening and why it is happening at this intensity, you have to understand what makes the American Central Plains one of the most meteorologically volatile regions on Earth. The geography of the United States creates a set of atmospheric conditions that essentially nowhere else in the world can replicate at this scale. Warm, moist air flows northward from the Gulf of Mexico, loaded with energy and instability. Cold, dry air pours southward and eastward from the Rocky Mountains and the Canadian North. Jet stream winds race through the upper atmosphere at speeds that create wind shear, the change in wind speed and direction with altitude that is the essential ingredient for rotating thunderstorms. When all 3 of those elements converge in the right proportions and at the right time, the atmosphere becomes unstable in ways that can produce supercell thunderstorms, the specific type of rotating, organized storm system that generates the vast majority of significant tornadoes in the United States. The spring of 2026 has put those ingredients together repeatedly and violently. As of April 24th, the United States has confirmed 451 tornadoes for the year, and that count is still rising as National Weather Service damage survey teams continue their work across multiple states. The season began above average in March, when a 3-event outbreak sequence included something that had not been recorded in the United States since 2013, an EF5 tornado, the maximum category on the enhanced Fujita scale, capable of destroying well-built homes and leaving no recognizable debris in the path. That March EF5 was the first in 13 years. It established the tone for a spring that has refused to slow down. The April 17, 18 outbreak, the largest single tornado event of the year so far, confirmed 80 tornadoes in a single day. The storm system moved from Oklahoma through Missouri, Illinois, Wisconsin, and Michigan, producing 2 EF3 tornadoes in Wisconsin, a state that rarely sees that level of storm intensity this early in the spring. Near Chicago, lightning strikes from the outbreak sparked house fires while storms were still moving through. Northern Illinois recorded 39 confirmed tornadoes in a single outbreak, more than any other state in that event. Despite the extraordinary scale and intensity of that outbreak, no lives were lost, an outcome that meteorologists and emergency management officials attributed to accurate forecasting, effective warning systems, and community preparedness that had been built over years of living in this environment. Then came the April 2024 sequence, which brought the Enid EF4 and continued the season's pattern of above-average intensity in areas not necessarily accustomed to the highest-tier severe weather. The Enid tornado was given its EF4 rating based on damage surveys conducted by National Weather Service teams the following morning, a rating that places it among the most destructive tornadoes of any spring in recent memory. The city's southern neighborhoods showed the kind of damage that EF4 ratings describe. Homes with exterior walls removed, large trees debarked, vehicles thrown significant distances. The fact that no one was killed in Enid that night is a product of both the warning that residents received and the choices they made with that warning. Now the pattern is building again. The atmospheric setup for Monday's outbreak follows a template that Storm Prediction Center meteorologists describe with specific precision. A surface low will develop Sunday across the Central Plains and move rapidly northeast, pulling a warm front northward through the Mississippi Valley. The dry line, the boundary between warm, moist Gulf air and drier continental air, will push eastward across the plains in the afternoon hours. When the cold front overtakes the dry line environment during the peak heating of Monday afternoon and evening, the energy that has been building in the warm sector will erupt into convection. Supercells are the expected storm mode in the highest risk corridor. The environment is forecast to support long-track rotating updrafts, the kind that can sustain a tornado for dozens of miles rather than the brief. Localized touchdowns that account for most tornadoes by count, but a minority of total damage. The St. Louis metropolitan area is among the locations that the Fox Forecast Center has identified as potentially facing significant impacts on Monday. St. Louis has a complicated relationship with severe weather. It has been struck by major tornadoes multiple times in its history, including an EF4 that caused extensive damage to the downtown and surrounding neighborhoods in 2011. The city sits in a position where the moisture transport from the Gulf, the cold air outflow from the northwest, and the jet stream dynamics frequently converge during spring storm setups. When the Storm Prediction Center identifies an area including St. Louis in a level 3 or higher severe weather outlook, emergency management officials in the region treat it as a day requiring active public communication and preparation. The question that severe weather researchers have been asking about the 2026 season is whether the pattern of intensity, the EF5 in March, the 80 tornado April outbreak, the Enid EF4, and now another major threat building, reflects something systematic about how the season is developing or whether it falls within the historical variability of American spring tornado patterns. The preliminary answer from seasonal forecast models and climate analysts is nuanced. The 2026 season was forecast to be front-loaded, more active in March and early April, with some models suggesting a quieter pattern by May in some regions. That front-loading has clearly materialized. Whether the continuing activity through late April represents the forecast pattern running longer than expected, or a more fundamental signal about how atmospheric instability is being loaded in this particular spring, is a question that researchers at NOAA and the Storm Prediction Center are actively examining. What is not uncertain is the scale of the threat that has already been documented and the scale of the threat building for the days ahead. 451 confirmed tornadoes by April 24th represents a pace that places the season well above the historical average for this point in the year. The EF5 in March was the first in 13 years. The 80 tornado single-day outbreak in April was the largest of the year. The Enid EF4 extended the season's record of extreme events deeper into late April, and now 55 million people are being told to monitor conditions carefully through Monday. The improvements in tornado warning technology over the past decade have genuinely changed the survivability equation for events of this scale. The average lead time for tornado warnings has extended significantly since the deployment of dual polarization radar technology, which allows meteorologists to identify the rotation signatures and debris signatures of tornadoes with greater precision and at greater distances than previous radar systems permitted. The combination of better radar, better atmospheric modeling, better public alert systems, including wireless emergency alerts pushed to mobile phones, and higher public awareness of shelter procedures has produced a pattern in the 2026 season that is striking. Extraordinarily intense storms producing far fewer fatalities than historical outbreaks of similar magnitude would have generated. The Enid EF4 with no fatalities. The 80 tornado April outbreak with no fatalities. These outcomes do not happen by accident. They happen because of a system, a science, an infrastructure, and a public culture of preparedness that represents decades of investment in understanding and responding to the severe weather environment of the American Central Plains. Every NWS damage survey team that maps the path of an Enid tornado is adding to the data set that improves the next forecast. Every upgrade to the radar network is giving the next warning a few more minutes of lead time. Every community that runs its tornado drill and knows where its shelter is reduces the gap between warning and survival. Monday's outbreak will develop. The supercells will fire in the warm sector. The Storm Prediction Center's models will track the rotation signatures. The warnings will go out across the Midwest and Mississippi Valley. And 55 million people who live in that threat zone will make choices. Where to be, what to monitor, when to move to shelter. That determine whether this outbreak adds to the spring's toll or continues the 2026 pattern of extraordinary meteorological violence absorbed with extraordinary resilience. The storm is building. The question now is whether the people in its path are ready for what is coming. The broader atmospheric context for why late April continues to produce these outbreaks connects to dynamics that operate at the continental scale. The jet stream, the ribbon of fast-moving air in the upper atmosphere that steers weather systems across North America, is in a particularly active phase for the northern spring. The temperature contrast between the warming continental interior, where surface temperatures have been running well above historical averages, and the still cold air masses sliding down from Canada creates a steep temperature. gradient that energizes the jet stream and makes it capable of supporting the deepening surface low-pressure systems that organize severe weather outbreaks into multi-state events. When meteorologists look at the upper-level charts for the coming week, they see the trough of low pressure digging into the Central Plains that is the classic setup for Monday's expected event. The role of the Gulf of Mexico as the moisture source for these outbreaks cannot be overstated. The Gulf is unusually warm for late April, with sea surface temperatures running above average across much of the western Gulf Basin, a condition that loads the air masses moving northward with more water vapor than climatological averages would predict. More water vapor means more latent heat energy available to thunderstorms when that moisture is lifted and condenses. More latent heat energy means more intense updrafts, larger hail, and the kind of organized, persistent supercell structure that generates the most dangerous tornado-producing storms. The warm Gulf is not the only ingredient in Monday's setup, but it is an accelerant that makes the other ingredients more potent than they would be in a cooler, moisture environment. The April 13-14 outbreak is worth returning to for a moment because it illustrates the depth of what severe weather intelligence has become in 2026. That single overnight event produced 39 confirmed tornadoes, 785 hail reports, and engaged 21 National Weather Service forecast offices across 7 states. The most remarkable hail reports from that event documented stones 6 inches in diameter, grapefruit-sized hail that can destroy vehicles, penetrate roofs, and cause serious injury to anyone caught in the open. The NWS damage assessment team spent days after the event conducting ground surveys, visiting hundreds of individual locations, mapping precise tornado tracks, and assigning damage ratings based on the physical evidence left by the storms. The resulting dataset, every tornado path, every hail point, every survey location, is added to a historical archive, spanning more than 125 years and 340,000 documented severe weather events. That archive is what allows scientists to track whether tornado seasons are starting earlier, whether the highest intensity events are becoming more frequent in states that historically saw fewer of them, and whether the geographic distribution of severe weather is shifting over time. The Wisconsin data point from the April 17-18 outbreak is particularly notable in this regard. 2 EF3 tornadoes in Wisconsin in a single April outbreak is unusual by historical standards. Wisconsin is not in the traditional tornado corridor that runs from Texas through Oklahoma and Kansas into Nebraska, the region sometimes called Tornado Alley. It sits in what researchers have been calling Dixie Alley's northern extension and the expanding zone of Midwest tornado risk that has been documented in recent decades.